Okay. First of all, I would like to thank the organizers of the conference for inviting me and giving me this opportunity and supporting my travel. And my name is Maksat Kulmanov, and I'm a PhD student in King Abdullah University of Science and Technology in Saudi Arabia. And today I would like to present our latest work. It's called Vec2SPARQL, and which is about combining SPARQL queries and knowledge graph embeddings. Yes. So with the recent development in machine learning and deep learning, there are a lot of different types of methods for learning knowledge graph embeddings and features from the raw data. For example, from textual data, we can use Word2Vec, the most popular one, to learn vector representations of the data from. We can also use different methods to learn from structured data, and also we can use methods for learning image features. And these features, these methods, they map our raw data into vectors, distributed number representations, which encode for semantics and can be used, for example, to compute similarities between the methods, and we also can use them as features in our classification models. So the questions that we are answering in this problem is, the main question is how to share these features, because people, they just upload their data and it's not very easy to use them. And we would like to make it easier for others to use these knowledge graph embeddings, and we would like to integrate them into the knowledge graphs that we use to generate these embeddings. So our solution to this problem is to use SPARQL, which is a query language for structured data, and it enables data sharing and also integration, because using SPARQL you can query multiple data sources using federate queries, for example. And Vec2SPARQL simply bridges the knowledge graphs, which were used to generate these embeddings, and the embeddings and vector space operations. So basically it provides a set of functions. Currently there are only two functions, which can give us, the first one is the most similar, which can give us the most similar entities, top and most similar entities to these embeddings in the knowledge graph. And the second one is the similarity, which can give us the value of the similarity of the entities in the knowledge graph. So these values can further be processed with the query. I would like to present one example of a knowledge graph of a clinical patients with their images, chest X-ray images. So what we did here is we used these images and applying the GoogleNet image recognition architecture, we extracted image features and put it into our database. And then using the SPARQL query, Vec2SPARQL can query these image similarities directly from the SPARQL using most similar functions. For example, here this query retrieves the 10 most similar images for the given patient's image. So as a result, we'll get 10 most similar images with their similarity values, and we can see here, for example, the first query image is the patient with a diagnosis atelectasis, and we get, like, for example, in top 5, 2 of the images also they have the same diagnosis. And this information was not included in the knowledge graph itself. And here are the images. You can also see that they are similar. So that's it. And I would like to, in this biohackathon, I would like to extend our method. And if you have any data set and you would like to use these features in your data set, then please contact me and we can work together. Thank you.
Okay, thank you.